They're bright, well-engaged people, and they need to be allowed to recognize current uncertainties that we have. We cannot go to them and say, we know what our flows are, we know what our demands are. Second, they need to understand climate forecasts and their limitations, and we'll come back to that in a few minutes. We need to estimate impacts for them, and finally what I would want to say is that we have to represent this for non-scientists in a way that's helpful to them, but do recognize they're accustomed to dealing with really hard problems, really complex problems. It's not that these people can't understand. They're solving problems in transportation and education and sanitation. It's that perhaps we're not formulating in a way that's useful. I'll just note at the bottom here the results of the Potomac study. The study that I worked on back in the mid-70s, the purpose was to build 16 new reservoirs in the Potomac Basin to make sure there was enough water for all that demand that was going to occur over time. We were able, through a series of projects, to illustrate that those weren't necessary. And what happened was that 2 small dams were constructed, not 16. And so the Shenandoah Valley was not flooded, the Occoquan was not flooded, and other places were not flooded. So I'm going to talk a little bit about climate forecasts. This has nothing to do with real climate forecasts. It only says that maybe in the south it's going to get warmer in the next 60 days. This is the NOAA forecast for April and May. So if you've been down in the south, maybe it's not going to be so bad in a couple of months. Okay, so what are experts saying about climate change forecast today? If you go to Google and you look, climate change forecasts, you're looking for the best source information, probably the first thing that comes up is this. Rush Limbaugh is very well noted as a climate, I'm sure Ray would follow, agree that it's very well noted as a climate science. And if you, literally, if you go, and I'll bring this back, just point back a little bit later, there are people who go to this source for information about climate change. But if you continue to Google perhaps just a little bit longer, you might come across a different source, and that would be the Intergovernmental Panel on Climate Change. And they're just now producing their next report. And so what has come out thus far is on the right-hand side. It's the summary for policymakers, and we're going to talk about that for just a little bit. And I will show a couple of graphs from the draft version of other reports, but I want to run through basically what is being said currently to policymakers about climate change. And I'm going to go through these fairly rapidly because there's a lot of them. And you're going to see a lot of dots because this report is full of long phrases. So let me just say the following thing. First, we'll talk about climate facts before we talk about forecasts. So we've had a warming climate, and everyone knows it's been warming. It's been warming in the atmosphere, and it's been warming in the ocean. Let me just illustrate this with 2 graphs. I think many of you are familiar with graphs like this. This is an illustration of the land-ocean temperature index from the 1880s to current, out to about 2012 or 13. And what you see here is a continuing rise since about 1910. You do see a flattening, and I think if you've been reading the literature, there's a lot of talk about why this has been flattening in recent years. But if you're clever and you want to make things look very positive, I guess you could do the following. The top graph looks at decadal averages, and this is being, I think, decadals that start with 4 and end at 3. And so what you can see over the last, basically from 1850 to 1910, fairly consistent temperatures, slightly going down, and then a rise after 1910 or so, flattening out in the 50s and a rise since that time. So warming climate over time. Another illustration, again from fact, over the last 2 decades, there's been ice sheets that have been losing mass and glaciers have been reduced. There could have been lots of figures here of different glaciers. This happens to be in the Cascades, an area that I'm familiar with, and this is just an illustration of receding glaciers over the last 80 years or so in the North Cascades, in a region that's just northeast of Seattle. In addition, another climate fact is that the sea level rise has been continual. So There, and I should note as I go along, there are many people in this room very familiar with this data, and I would have to argue much more expert than myself, and hopefully I'll present this in a reasonable way. But here's Arctic summer ice extent in terms of millions of square kilometers over time. Some is estimated. The gray areas represent some confidence bands, but you can see it dropping dramatically since over the last 30 years. And global average sea level change. And on the right-hand side, those are estimates of inches, approximate inches on the right-hand side. Okay, those are facts, and so some forecasts are being made by the IPCC, very consistent with what they have done before. The forecasts are that the climate change by the end of the 21st century will likely exceed 1.5 degrees centigrade relative to 1850 and 1900. So the IPCC is using a different type of forcings than they had in the past. If you're used to the SRES forecast, they were based on scenarios of growth in population and economic activities. And these have been replaced by what's called representative concentration pathways. There's a close relationship between some of the RCPs and the past forecasts. But let me I'll leave it to say that these are ranges of time it takes for the CO2 to double over time. And also the global mean temperature will continue to rise. These two figures here, one looking at temperature, the bluish or purplish is looking at models that tend to have an increase in CO2 at a much slower rate than the red models, but both indicate increases in temperature over time. And then the global sea level rise by 2100 being as much as about 2.5 feet on average for some of the higher emission scenarios. So, climate impacts. So we looked at real quickly at some of the data of what's happened in the past and what's being forecasted to happen. And these, of course, are all pictures of impacts of Sandy, not too far from us. So there's in the IPCC report, there's a list of identified climate impacts. And again, I'll try to go through these really quickly to get on with the other part of our talk. Terrestrial marine species having shifted their ranges, and these are identified impacts from the past. Terrestrial freshwater species face increased extinction, and many regions, precipitation and melting snow having been significantly altered relative to the hydrologic cycle. And then further future impacts, not ones we've seen, but sea level rise throughout the 21st century and beyond, coastal systems becoming increasingly experiencing adverse impacts. And then finally, estimates by 2100, hundreds of millions of people being impacted. I just pulled this out. This is not from the IPCC report, but I just wanted to illustrate the kinds of impacts that we're talking about.